Hello everyone, welcome back to my YouTube channel. As you all know that myself Pratibha sir from Sri Venkateshwara College of Engineering in the Electronics and Communication Department. In today's session, I am going to discuss about AM circuits which comes under the transistor modulators in the course called Principles of Communication System. But before going to the topic, firstly, let us go through the contents. In this session, we are going to learn about the introduction to the AM circuits, definition of the AM circuits, types of AM circuits, and the transistor modulators. First, introduction to AM circuits. AM was the earliest modulation method used for transmitting audio in radio broadcasting. This original form of AM is sometimes it is also called as double sideband amplitude modulation, in short form DSAM, because the standard method produces sidebands on either side of the carrier frequency. Single sideband modulation, it uses bandpass filter to eliminate one of the sidebands and possibly the carrier signal, which improves the ratio of message power to total transmission power, reduces power handling requirements of line repeaters, and permits better bandwidth utilization of the transmission medium. The AM remains in use for many forms of communication in addition to the AM broadcasting, short wave radio, amateur radio, two-way radios, VHF aircraft radio, citizen band radio, and in computer moderns in the form of QAM. One of the disadvantages of all the amplitude modulation, which is called as AM technique, not only standard AM, it is that the receiver amplifiers and detects noise and electromagnetic interface in equal portion of 10 decibel improvement. Thus, would require increasing the transmitter power by a factor of 10. This is contrast to frequency modulation FM and the digital radio, where the effect of such noise following demodulation is strongly reduced so long as the received signal is well above the threshold for reception. For this reason, the amplitude modulation broadcast is not favored for music and highly fidelity broadcasting, but rather of voice communications, and the broadcast is like are used for sports, news, and talk radio, etc. Here, the figure shows an audio signal which is in the top may be carried by the carrier signal using the amplitude modulation or the frequency modulation. The figure shows that the audio signal which is at the top, it is carried by using the carrier signal. Here the carrier signal is the it uses the amplitude modulation or the frequency modulation methods to carry the signal. Definition of AM circuits. Amplitude modulation, which is nothing but as AM, it is a modulation technique used in electronic communication most commonly for transmitting the necessary messages with a radio wave. In amplitude modulation, the amplitude signal strength of the wave is varied in proportion to that of the message signal, such as an audio signal. This technique contrasts with angle modulation, in which either frequency of the carrier wave is varied, as in frequency modulation, or its phase, as in phase modulation. In electronics, telecommunications, and mechanics, modulation means varying some aspects of a continuous wave carrier signal with an information bearing modulation waveforms. These modulation waveforms may include audio signal, it represents sound, or a video signal which represents the images or videos. In this sense, the carrier wave, which has a much higher frequency than the message signal, it carries the information. At the receiving station, the message signal is extracted from the modulated carrier by demodulation. In general form, a modulation process of a sinusoidal carrier wave, it may be described by the following equation. The equation is m of t equals to a of t into cos omega t plus phi t, where a of t represents the time varying amplitude of the sinusoidal carrier wave and the cosine terms is the carrier at its angular frequency omega and the instantaneous phase deviation phi of t. This description directly provides the two major groups of modulation, amplitude modulation and the angle modulation. In angle modulation, the term A of t is constant and the second term of the equation has a functional relationship to the modulating message signal. Angle modulation provides two methods of modulation, namely frequency modulation and phase modulation. In AM modulation, the angle term is held constant and the first term A of t of the equation has a functional relationship to the modulating message signal. The modulating message signal may be analog in nature or it may be digital signal, which case the technique called amplitude shift keying. Now let us see the types of AM circuits. Amplitude modulators are generally one of two types. Low level. These modulators generate the amplitude modulation with the smaller signals. The second one is high levels. These modulators produce AM at high power levels, usually in the final amplifier stage of the transmitter. Lower level amplitude modulations are transistor modulators and the diode modulators, and in higher level amplitude modulators, the collector modulator. Now, let us see the transistor modulators. In typical transistorized amplitude modulation circuits of a prior odd, the carrier voltage, which is applied to the base electrode of a linearly amplifying transistor, and the transistor gain is varied in accordance with the modulating voltage applied to the transistor base or the collector electrode. Here we can see the figure or the circuit diagram of the transistor modulators. Next, simple transistor modulator. A improved version of the circuit is shown in the figure. The improved version is shown in the respective figure. It uses the transistor. It uses a transistor ahead instead of diode. The circuit has a gain. The emitter-base junction is a diode and a non-linear device. Modulation occurs as same as the diode modulator, except base current controls a large collector current. Rectification occurs because the emitter-base junction is present. Rectification is occurred due to the presence of emitter-base junction. It causes for a large half sine pulses of the current in the turned circuit. It causes the large half sine pulses. Next, the turned circuit oscillator to generate the missing off cycle. Here we can see in the diagram what are all the changes and the waveforms are producing. It is a simple transistor modulator. An improved version of the circuit is described in the figure. It uses the transistor. The transistor modulator uses the transistor instead of diode. Then the circuit will has the gain. The base emitter junction is a diode. The base emitter junction will act as a diode and a non-linear device. And the modulation occurs as same as the diode modulator except base current because it controls a larger collector current. Then the rectification occurs because of the emitter base junction. This causes for a large half sine pulses of the current in turned circuit. The turned circuit oscillator is used to generate the missing half cycle. Thank you.